To study the impact of third-degree price discrimination, let's work through a simple example. Suppose that the price elasticity demand for Atkins cheesecake nationally is minus 2.5. It's 2 on the East Coast and it's 3 on the West Coast. This means that the demand on the East Coast is more inelastic than the demand on the West Coast, or the demand on the West Coast is less inelastic. Less inelastic is the same as more elastic, and more inelastic is the same as less elastic. Bottom line, folks on the East Coast are less responsive to changes in price than folks on the West Coast. Now suppose that Atkins charges the same price everywhere. We'll make another assumption, now we're told that marginal cost is equal to $20. If marginal cost is 20 and we're pricing a good whose price elasticity is 2.5, the optimal pricing rule will give us that the optimal price is equal to $33.33. On the other hand, if we discriminate in price and charge a different price on the East Coast and the West Coast, our optimal pricing rule for the East Coast tells us the optimal price is $40, and the optimal price on the West Coast is now going to be $30. A couple of conclusions emerge from this pretty quickly. First, we see that price has gone up in the market that is more inelastic. That's a general conclusion. When you go from non-discrimination to discrimination, price will rise in the markets that are more inelastic. On the other hand, price in the West Coast market has gone down. It's also a general rule. The prices in the market that is more elastic will be lower with discrimination than without. This also means that the margin will be higher in the East Coast market, margin of price for marginal cost, and margin will be lower in the West Coast market. Finally, the increase in price is going to make the quantity demanded go down in the East Coast market relative to what would occur without discrimination. And the decrease in price on the West Coast will make quantity go up relative to what would occur without discrimination.